And I want to say good Wednesday evening and welcome everyone on behalf of the Arizona Institutes for Resilience, the Desert Laboratory on Tumamoc Hill, Arizona Public Media, and all of our panelists and partners to Fire and the Future, Tucson's Bighorn Fire, 1 year later. It's already been almost a year. We thank you for spending part of your Wednesday evening with us to talk about something that was so impactful last year. And as we're learning more each day, finding out how much more of an impact this is going to have in the long term, for better or worse. And that's why we have the best experts with us tonight to talk about those things. I would like to begin by introducing Jim Buizer, who is a director of the Arizona Institutes for Resilience, who will say a few words about tonight's webinar and about that Bighorn Fire. And Jim, good evening. Welcome.
Yeah, thank you, Tom. So as Mr. McNamara said, my name is Jim Buizer. I'm at the University of Arizona, where I serve as the founding director of the Arizona Institutes for Resilience, and also as a professor of climate adaptation and international development in the School of Natural Resources and the Environment. The Arizona Institutes for Resilience, or AIR as we call it, is a new constellation of 11 research programs, centers, and institutes, including the Desert Laboratory on Tumamoc Hill, the Center for Climate Adaptation Science and Solutions, and the Southwest Climate Adaptation Science Center, who, along with the Arizona Public Media, serve as production partners for this event. As part of the Office of Research Innovation and Impacts, led by Dr. Betsy Cantwell, AIR coordinates interdisciplinary groups of faculty, students, and projects across the University of Arizona's campus, from climate science to public policy, law, the arts, water resources, and beyond, to explore and develop research-based resilience solutions that serve human and natural communities here and by extension across the globe. We're very proud to offer this free public webinar, Fire and the Future, Tucson's Bighorn Fire 1 year later. It is our honor to be able to provide you with the insights from world-renowned experts to address the evolving and expanding role of fire in the West. Fire is and will continue to be one of the greatest drivers of change in modern times, especially in the Western US. Our goal is to better understand not only the Bighorn Fire that engulfed our Catalina Mountains a year ago, but the complex interactions between climate change, invasive species, management practices, policy, and economics that are shaping our future. A year ago, on a dry and gusty Friday evening, a lightning strike started the Bighorn Fire, the largest fire in the recorded history of Pima County. After a month of high winds and remarkable firefighting efforts, saving the town of Summerhaven and a few other populated locations, nearly 120,000 acres had burned, changing the face of the Catalina Mountains for generations. This event did not happen in isolation. Last year, more acres burned in Arizona than any other year in the state's history. Fire touched many of our communities, both in the desert lowlands and the forested mountains. A host of questions emerged as we witnessed our mountains ablaze in our backyards, including my own, where I had a front row seat to watch the firefighting effort, and all across the West. What was the role of invasive species? What role did climate change play? As at many points this last year, the situation seemed to get worse as the weeks went on. Is this the new normal? These are some of the questions we will hear answered tonight. This webinar is just one example of the many ways the University of Arizona demonstrates leadership in the understanding of our environment and in communicating findings to the broader community. Our climate is changing, and this has real-world impacts for all of us. Going on 12 months with almost no rain, the stress on our collective region is mounting, fire danger being one of the ripple effects. In the next hour, you'll hear about what we can expect in the future and how we can adapt to novel and changing conditions. Finally, I would especially like to thank AIR's Desert Laboratory on Tumamoc Hill's Ben Wilder and Roseanne Hansen for making this webinar happen, and to acknowledge tonight's amazing panelists and moderator Tom McNamara, who are sharing their valuable time with us this evening. I'd also like to thank Sarah Smallhouse, a leader of our community, for spearheading this webinar series. And for all of you with us this evening, I thank you for joining us for what promises to be a fascinating conversation. Back to you, Tom.
All right, Jim, thank you so much for your time and for your nice words this evening and your involvement in this webinar. We certainly appreciate that. And before we get started with tonight's main topics here, I have a couple of Zoom tips for the webinar to make things go smoothly. If you will, please use the Q&A area button at the bottom to submit your questions for the panelists. And we'll be getting to those right after 7 o'clock this evening at the end of the presentations. The Q&A with the panelists will be at the very end of the webinar, and we'll try to choose a broad cross-section of questions that you submit. The webinar is live captioned, so if you'd like to turn on the English captions on Zoom, click the CC button at the bottom of your screen there. If you'd like captions in Spanish, please refer to the link we've provided in the chat, and you'll find that there. The webinar is being recorded, and we will be posting it in about a day on the Arizona Institutes for Resilience website. All right, you heard his name a moment ago, and he is our first speaker tonight, Dr. Ben Wilder, director of the Desert Laboratory on Tumamoc Hill, the historic 118-year-old field station that integrates science and culture to understand the future of life in our fragile desert. The Desert Laboratory is a center of the Arizona Institutes for Resilience, all tied in nicely together. Ben, welcome. Thank you for your involvement once again in this webinar and the series last year in 2020 that was very successful and informative. And if you will, Ben, start off by reminding us about the scope and the nature of the Bighorn Fire.
Yeah, thanks, Tom. It's a pleasure to be back with you. So it was quite the event. And so I'm just going to kind of do a quick recap of the event that happened on Babadoag, or the Atam name for and on whose land the event we're talking about, that name meaning Toad Mountain. And essentially on June 7th, 2020, a dry kind of lightning storm came through. I don't know if anybody remembers that. It was a really kind of an interesting event, and this one of those lightning strikes actually struck on you can see in the bottom left there of the screen, right on the kind of near Push Ridge, or the Bighorn Peak on the Catalinas, and that started this fire. And when the first couple of days, you just saw the progression there, in short order. What you're seeing right now is that northern slope, kind of near Catalina State Park and the Push Ridge Wilderness. It quickly then moved and was pushed by a lot of fuel, and we'll be talking about what that fuel type was here a lot tonight, but also winds, just kind of like this year. Abnormally windy June, and it really moved that fire, dropped down the front range of the Catalina Mountains into forcing kind of unprecedented evacuations of the Catalina foothills. And then I felt kind of like a snake. The fire just wound its way through the mountain range up to the north slope, threatening Summer Haven, and then down and further to the east, and then really petering out as it approached the Reddington Pass area and dropping into the San Pedro watershed valley there. And you can see Summer Haven was saved, but burned all around. And we'll be talking, and a lot of the images you see right now are the sites where a lot of the ecological plots that you'll be hearing about later tonight are focused. In all, it consumed about just shy of 120,000 acres, and as Jim said, is one of the largest, the largest event in our region. I think it's important to note that this was not the only fire happening at that time in our area. Just outside of Phoenix, there was the bushfire, and also a very large fire that started in the deserts and went up. So it was quite the impactful event that we'll be remembering for a long time.
All right, Ben, thank you. We know you'll be standing by, more to come from you very shortly, but joining you now is Dr. Julio Bettencourt, who is Scientist Emeritus at the National Center of the U.S. Geological Survey. And Dr. Bettencourt spent the majority of his career as USGS Director at the Desert Laboratory on Tumamoc Hill. He and Dr. Wilder are among a team of scientists who have spent the latter half of 2020 studying the Bighorn Fire. And Dr. Welcome, and start out by asking you, one of those lasting images from last year's fire are the burned saguaros. Isn't fire in the desert extremely rare? And can you explain how the situation has changed? And it's already been mentioned, are the invasive species like the buffalo grass majorly involved here?
Good evening, Tom, and thanks for that important question. You know, even as recently as the 1960s, ecologists considered the Sonoran Desert as mostly fireproof, mostly due to the wide spacing of trees, shrub, and cacti and the prevalence of barren soil. Because of the lack of continuous soil, you can actually, a continuous fuel, you can actually, douse a saguaro with gasoline and the fire's not going to spread anywhere. But that is actually, changed. It's changed dramatically, even as recently as the 1960s. This began to change in the 1970s with the rapid invasion of non-native flammable grasses like red brome and bufflegrass. These non-native grasses are filling in what was formerly barren ground and creating new fuel continuity. And it's altered wildfire regimes that are now grassifying desert grasslands, not just in the Sonoran Desert, but across all of the North American deserts. So grassification can occur without fire simply by invasive grasses outcompeting woody plants for water, nutrients, and space. But the transformation can occur much faster with wildland fire through something that we call the grass fire cycle. So here's just a brief cartoon showing what we consider to be the grass fire cycle with, invasive grasses filling in the barren soil in between the trees, shrubs, and cacti. A fire starts, it kills the native shrubs and cacti, and then after the fire, non-natives recover more rapidly than native species, and then the infested area burns repeatedly. In a matter of years to decade, fireproof desert is converted to flammable grassland. So every time this repeats itself, the frequency, size, and severity increases. And eventually this leads to not only risks to natural resource, but also to life and property. And of course, regional economies suffer. So when I moved to Arizona in 1976, sorry about that. Wildfires fueled by red brome seldom exceeded a few thousand acres, usually just a few hundred acres at most. But burned area has increased exponentially in the 21st century. In 2005, after an unusually wet El Nino, there was a phenomenal bloom of red brome, creating unprecedented fuels across the Sonoran and the Mojave Desert. So 250,000 acres burned during the Cave Creek fire north of Phoenix, and then 750,000 acres burned in southern Nevada from Las Vegas to the Utah border. And then there were several fires exceeding 50,000 acres in southwestern Arizona and southeastern California. So newspapers throughout the region posted spectacular photos of scorched saguaros and Joshua trees. I remember talking to a regional science writer named Chris Clark, and I referred to 2005 as the year we lost the desert, which became the title of the story. So another novelty in the 2005 fire season was the spread of broad ignition fronts from the desert valleys to the forested mountains, threatening to change the whole fire mosaic in the region. So Ben Wilder and Liz Baldwin, who is here with us, and I, along with colleagues at the University of Arizona, the Desert Museum, and USGS, recently completed a study of the Bighorn Fire and its spread into Palo Verde saguaro communities in various stages of bufflegrass invasion. We think this connectivity of wildfires across biomes could in fact be the wave of the future.
Doctor, thank you. And we know you'll also be standing by for more to come shortly, but what you've mentioned about the magnitude of fires from the 1970s, your first exposure here, to now getting worse and worse. I'll ask Dr. Wilder a very broad question, but on that basis, what is the outlook for the future of wildfires in the desert?
Yeah, Tom. So unfortunately, we can expect that there are increasing areas of desert that are going to burn looking forward. And this is really due to two main forces that are at play here. So one is increasing invasive flammable grasses or grassification and that grass fire cycle Julio just described. And the second being a essentially increasing fuel loads of these species as well as native species in response to wet El Nino years that amplify that fire frequency. So specifically, 2005, the year Julio mentioned, and last year, 2020, were really wet years that created this fuel load, but it's more than the baseline or the prior to the introduction of and the presence of invasive species. So you just have more fuel to burn at lower elevations that, as Julio described, largely were fireproof. So essentially what you're seeing here is kind of this large infestation. Everything you see there in brown is buffalo grass. And it's a very, very flammable grass. It evolved in a savanna grassland ecosystem. So it burned. That's part of its lifestyle and life history. And essentially, as many areas of the Catalina foothills look just like this and are heavily infested. So it's not too hard to imagine a fire essentially rotating and roaring through this area, unfortunately jeopardizing many of those saguaros. Kind of caught in the middle here is the wildland urban interface. And really what I'm talking about is the homes, are parts of our city that are right at the edge of the urban area, urban core, and at the fringes of wilderness. So the Catalina foothills are a prime example of this based kind of, and they were at the forefront of the edge of the Bighorn Fire this last year. So we saw unprecedented evacuations of the Catalina foothills driven by this threat of buffalo grass. And that fire creeping down slope. So it's really interesting and I think important for us to keep in mind the economic considerations here, which we'll talk a little bit more about in a bit, but that they are really kind of, I would say, in the middle and the crosshairs here is not just in our community, but in many communities across the West in our sprawling cities. Some of that high-priced real estate where many parts of our communities are focused is right at this desirable edge of the wildland urban interface, right? And a lot of questions is how desirable is that going to be in the future? So kind of looking forward a bit, there is essentially what we have right now is fires have been contained at higher elevations. And as we think of them as forest fires, and there's been kind of a break right around 4,000 feet or 1,200 meters, which is right where the desert transitions into the grasslands above. And above the grasslands, that's an area that has had fires, right? That's where fires are contained, and the deserts have not really had that fire. And so where we're getting to in the near future is essentially a situation where we have higher connectivity. And that break that you had at the 1,200 meter line isn't there anymore. And it's driven by what you're seeing in that video right there, that continuous fuel load of these perennial bunch grasses, buffalo grass, or even in wetter years, the annuals, jeopardizing these homes that we're seeing. And so that is creating a scenario when essentially you can have fires starting in the desert lowlands and working their way upslope into the forests above, or vice versa, starting in the forest and working their way downslope, unfortunately, into the valley below. So this is an image just kind of depicting that kind of present, what we have at kind of now and maybe the last several hundred years as an example of our chaparral or sky islands. And into the near future, we can have essentially this connectivity that's linking our wildland urban interfaces, jeopardizing much of the high value real estate in our community, the Catalina foothills, but also the tourism that really underlines, just thinking of the backdrop of the view from Lowe's Ventana Canyon. This image here really shows the spread of buffalo grass in the turquoise polygons and the edge of the Bighorn Fire in red. And if you look closely, you can see that they don't overlap a lot. The buffalo grass is at elevations below that 1,200 meter line. And really, You see the most area in this figure is showing that the buffalo grass is right below that transition at 1,000 meters. The takeaway here is that the Bighorn Fire was a near miss. We did not get the fire dropping in and thankfully did not get the fire in taking out many houses because the buffalo grass hasn't colonized that area yet. Unfortunately, we think that this is a snapshot in time, this figure, and that at that 1,200 meter level, higher in elevation, especially given warming temperatures, we expect the limit of buffalo grass to be lifted and it to fill in that area and to create this connectivity and the increase of fires in the desert.
All right. Ben, thank you for the scientist, the homeowner, lots of food for thought going forward out there. And joining you now and Julio as well as Dr. Elizabeth Baldwin. We welcome Dr. Baldwin in. She is assistant professor at the University of Arizona School of Government and Public Policy, who has also been involved in studying the Bighorn Fire from her perspective now. Dr. Baldwin, thank you. You've been pretty busy. Tell us about your survey on the fire, which of the stakeholders you're reaching out to, and how you're using social sciences to address the evolving threat of fire.
Thanks, Tom. It's great to be here. So my U of A colleagues, Jose Soto, Aaron Lean, and I recently completed a survey of over 500 Pima County residents. And we worked really closely with an online survey research firm to get a sample that's demographically representative of the county at large. So this survey really provides the first comprehensive overview of residents' knowledge and attitudes towards buffalo grass. And because we launched the survey in response to last summer's Bighorn Fire, it also gave us an opportunity to assess how exposure to the fire has shaped people's attitudes. We actually had about 150 of our survey respondents were people who had been either evacuated themselves or had had family or friends who were evacuated due to the fire. So we're still working on the analysis, but I would love to share with you 3 preliminary findings from the data. So first, we found that Pima County residents know about buffalo grass. Just over half of our survey respondents had heard of buffalo grass, and about the same percentage were aware that buffalo grass increases fire risk. So this is demonstration that word about the risk of buffalo grass has spread in the community. Really interestingly, among people who were personally evacuated due to the fire, those numbers increased to about 75% of respondents who were aware of buffalo grass and how it affects fire risk. The second finding I'd like to share is that when people think about the risks associated with buffalo grass, their biggest concern by far is fire risk. So we asked survey respondents to rank 5 buffalo grass related threats from most concerning to least concerning, and about 70% of them ranked wildfire as the #1 threat, compared to just 13% of people who were most concerned about buffalo grass as a threat to the saguaro cactus. Then the third finding is that people expressed a lot of political support for efforts to address buffalo grass. So in the survey, we asked people if they would vote yes on a hypothetical referendum that would add a couple of dollars to people's monthly utility bills to create a fund for buffalo grass removal. And just over half of our respondents said that yes, they would vote yes on such a referendum. We actually gave them a number of different hypothetical referenda, varying some of the details about how much each would cost, who would administer the funds, and so on. And consistently across all of these hypothetical referenda, at least half of respondents said that they would vote yes. And something perhaps more interesting, this level of support was pretty consistent regardless of political affiliation, age, or income. So support among Republicans was a little bit lower and support among Democrats was a little bit higher, but there was significant support across the political spectrum. And the last thing that I'd like to add is that this survey is just one part of a larger project that's funded by the National Science Foundation to investigate buffalo grass, not just from an ecological perspective, but also from a social perspective. So the particular survey that I just reported some results on was focused on public opinion, but moving forward, we'll be talking to public and private land managers to get a better sense of how they think about buffalo grass and whether they would support similar policy proposals.
And Doctor, I think you've led us up nicely to the next question, and that is, how can your studies perhaps help to craft public policy to address things like the buffalo grass, the invasive species, and fire?
Yeah, Tom, I'm glad you asked because that's front and center in what we're doing in this project. And I think the first thing is that these results show policymakers that they really need to have bufflegrass and wildfire risk on their radar screen. So our survey shows that local residents know about bufflegrass, they're concerned about the fire risk that it presents, and there's pretty strong bipartisan support for funding bufflegrass removal. The second thing that I'll add is that we all know that if policymakers are going to try to initiate any kind of program to fund bufflegrass removal, that the details of the program really matter. There are design details like how much it would cost taxpayers, who would administer it, what areas would be prioritized for removal. And these details really matter to the public. And as we move forward with our survey analysis, we'll actually be able to provide policymakers with information about how some of those design choices might affect the public's support for this kind of policy initiative.
All right, thank you. And while you're there, we'll invite Ben and Julio back in. And I'd like to ask Julio, generally speaking, how should we be thinking about the changes that you are all describing this evening?
Well, Tom, I've used the term grassification for a reason, because I want to focus our attention on the fact that this is below 1,200 meters in elevation in the west. This is the most important thing going on right now, is this invasion by exotic grasses and then these novel wildfire regimes that link across biomes. I mean, we've got to understand that this is a significant challenge that's further complicated by things like climate change, urbanization, and myriad issues that are mostly spatially extensive environmental problems that cross jurisdictions. And none of these problems are happening in isolation, and their mitigation and adaptation are intrinsically linked. That's something that we really have to understand. And that if we capably address one of the problems, that it serves as a template for addressing the others. So this is really important. So to adapt, we need to understand how grassification and shifting wildlife regimes are affecting not just biodiversity, but disrupting energy flow, nutrient cycling, and the transport, supply, and quality of water and sediment. Right now, lamentably, these questions remain unanswered. Ecosystem transformation is well underway in places like the Catalina foothills, and we need to simulate and prepare for novel landscapes. Mitigation is complicated and depends on specific objectives. Eradication of things like red brome and bufflegrass is out of reach. So we need to pick our battles wisely. For example, mechanical and chemical treatment options to prevent cross-biome fire spread could be prioritized according to landscape structure, predicted fire behavior, and risk to natural resources and public safety and property. So this prioritization could apply to the airdrop of flame retardant from fixed-wing aircraft during wildfires, and it could apply to pinpoint application of herbicides from helicopters in steep and inaccessible terrain of the Catalina foothills. Mitigation won't come easy or cheap, requiring institutional focus and tens of millions of dollars sustained over the long term.
And Ben, here we are. I'll ask you, 1 year later, 2021, can we turn back the clock, or is it more a question of adaptation going forward?
I don't think any of us want to turn back the clock to 2020. So we're going to be needing to look forward. And truly, we really, as Julio just described the situation, these are large-scale processes and mechanisms that are greater than I think they're greater than a human scale. And so these are forces are at play, things are in motion, and doing what kind of is referred to as rear view mirror restoration or management is not going to get us to where we need to be. So looking at that rear view mirror is taking you to what it used to be. But we know that that's not the trajectory things are on. And we also know, given the paleoecological record that change is the name of the game. Ecosystems get reshuffled. Species respond in an individualistic way to climate change. And that reshuffling is happening now. And one of the things I think is so important about this webinar and this series is the role of fire in driving that change. And so we need to be looking forward and doing this adaptive management in a realistic framework. And I think a lot of the comments tonight are trying to help us get our head around what that realistic framework is. And as kind of Julio mentioned, it's picking our battles, picking our priorities, and maybe just two examples within our community. One that is my job here at Tumamoc Hill. For those that know, we have a massive bufflegrass infestation here, covering about 190 of the 860 acres of the site. But we are working with the Desert Museum and have support financially to control that, because this is a high value site. Likewise, I would argue that much of the Catalina foothills is also a high value site. And I mean, we've been talking, but I believe that $10 million is a kind of a number that is a game changer for controlling the expansion and that continuous fuel loads. And we know what's going to happen if we do nothing, which is quite extreme. But kind of putting that in context, I think $10 million is, if you take several of the property values that are in that wildland urban interface I was discussing, and sum those, I think that well exceeds that $10 million threshold. So thinking at a societal and political level where we invest these resources to try to stay ahead of the curve and be proactive is a really important element for us to consider.
All right, well, we want to thank all three of you, Ben, Julio, and Liz, and ask you to stick around. Of course, we're going to be having some questions in just a little bit while.
If you don't mind, Tom, I would actually, I think we may have just a couple more minutes. I'd love to ask Liz to kind of provide a little bit maybe of a kind of a socioeconomic perspective on this.
Sure. Yeah. Just a quick comment, because both Julio and Ben have mentioned the costs of mitigation. And I wanted to just add that not just thinking about the cost of mitigation, but the cost of not undertaking mitigation. And when I first started researching this problem, I did not fully realize that bufflegrass presents the grassification challenge that Julio mentioned. I didn't realize that we face the threat of an ecological state change. And so $10 million may sound like a lot of money, but when you think about the significant future costs that would occur, putting wildfires out, paying higher costs to insure our homes, to rebuild them after fires, and to deal with the blows to decrease tourism revenues and a really diminished quality of life, that kind of investment doesn't look so expensive.
All right. Well, Liz, thank you. And again, thanks to all three of you. More to come on our question and answer. I've been watching. We have quite a few questions have already rolled in. So we will sift through those and get to those in just a little while. But once again, our thanks for all of your great input this evening. And next up, we're going to speak with University of Arizona researchers Emily Foulé and Rebecca Beers, who have just begun a wide-scale project this week working with Dr. Don Falk in the School of Renewable Natural Resources and with Dr. Ann Yauberg of the Arizona Geological Survey. And Don will be joining us in just a little while. But Emily, we'll begin with you. You're the lead in this study, so congrats. And can you please tell us a little bit about why it's a unique study with multiple disciplines involved with what you're doing?
Yeah, hi, Tom. Thank you. So with this study, we're interested in researching several things. First, we want to see the ecological impacts from the Bighorn Fire last year in 2020, and to see how the burned areas, especially up in the pine forests, are beginning to recover. And second, we're interested in the ecological impacts of multiple burns, where the same location burns more than one time. In the Catalinas, in 2002 and 2003, the Bullock and Aspen fires burned much of the top of the mountain. And then, of course, last year in 2020, the Bighorn Fire burned over many areas that had already burned in these previous fires. So one important aspect to our study of reburns is the severity at which the fire burns in each event. And fire severity is classified as low, moderate, or high, where low severity fires mostly burn pine needles and small plants. Moderate severity fires burn hot enough to kill small trees and shrubs, and high severity fires burn large trees, killing even adult mature trees, as well as, of course, smaller plants. So our study this summer focuses specifically on these areas that burned both in the Bullock aspen and then again in the Bighorn, but that also burned at different patterns of fire severity. And you also mentioned the multidisciplinary aspect, and we're really fortunate to be able to work with our hydrology and soil science colleagues to look at the biggest and most complete picture that we can of our sites. And what's happening below ground is, of course, really important, and it's a big driver of what we end up seeing above ground. And collecting data on hydrologic properties of the soil and nutrient contents, they're really valuable to us to help explain the variation that we see in plants and their recovery, of course, as well as being valuable data on their own.
Well, great. Now we're gonna head virtually to the mountain, Emily, if you will, to one of your research sites to see firsthand how fire research is conducted and learn why the research team chose the sites that have had multiple fire impacts that go back decades now. And we'll ask you and we'll ask Rebecca to narrate the segment as we go with the video. So please take it away.
Sure. So these maps are a great example of different patterns of reburns, and the different colors, the yellow and then orange you'll see in a second, represent different patterns of fire severities. So for example, the yellow burned at low severity in the Bullock aspen and then moderate or high in the Bighorn. And these maps also show the scale of these fires and how much of the area that burned in 2002 and 2003 burned again in the Bighorn, which I think really highlights the importance of research into multiple fires and reburns. And in this shot, we can see a few different fire severity patterns. So the middle ground, where there are no large trees at all, burned at high severity in both fire events. And then further back, where there are standing trees that have brown needles, it didn't burn in the earlier fire, but it did burn in the Bighorn. And then even further back, which you can't see as well anymore, where there's the stand of live trees, it didn't burn at high severity in either fire. So even in just this one landscape shot, there are several different severity patterns very close together. In this next shot, the background slopes again burned at high severity in the Bighorn, where the foreground, where there's live trees, I don't think those burned in the Bighorn fire. And so again, you can see the different patterns. And likewise, in this shot across from the ski valley, the slopes in the background burned, and in the foreground, they did not. So to really see the effects of these burn patterns, myself, Rebecca, and a crew of U of A students are going out to collect ecological data in the field. And we're hoping to go to over 80 different plots across the Catalinas to record information about live and dead trees, understory growth, and seedlings, among other things. And seedlings are a really important indicator of what the plots will look like in the future. Although for plots that we're going to that burned at high severity in the Bighorn, it's likely too early to start seeing pine tree or fir seedlings. We also collect data on how healthy the remaining trees are. For example, one measurement we take is the height of the canopy. So from the bottom of the live needles or leaves to the top of the live needles or leaves, which is an estimate of the photosynthetic capacity of the tree. And it's a good proxy for how healthy they are and how much they'll be able to grow. These ferns that you're seeing right now are a really common post-fire species that we're already seeing come back after the Bighorn. And you can really see that recovery is already beginning in many of these areas, even ones that burned at high severity and even just 1 year later. And just to cap off, why should we care about reburns? As wildfires become larger and more frequent, more areas like the Catalinas will start to burn twice or even 3 times in a relatively short amount of time. And at the U of A, we're working with scientists from the Coronado National Forest and the US Forest Service to see in real time how our forests are being affected by reburns. And we really hope that our research will provide them with the ideas to help make our forests more resilient to wildfires and reburns.
Rebecca, we'll ask you to weigh in here a little bit. I know the study is new, but what's been very eye-opening for you at this point, and what do you see as the big challenge ahead?
Hi, yeah, thanks for having me. So I'm going to give a little overview as to what we're doing with our soils research portion of the study. So once again, I'm working with Emily, and what we're trying to do with the soils research is to understand how the soil properties vary between areas that were burned only in the Bighorn versus soils that were previously burned in the Aspen or Bullock fires, and then again in the Bighorn. So essentially, wildfires impact the physical and chemical properties of the soil, which often leads to the soil surface becoming hydrophobic or water repellent. And we care about this because hydrophobic soils have limited ability to absorb water, which means that when it rains, we're likely to see increased runoff and are at higher risk for flooding and debris flows. So here in the video, we're using infiltrometers to measure how well the soil can absorb that water. And the benefit of collecting these measurements across the landscape is that we can compare infiltration across areas where soils have burned once versus multiple times. And we want to know how this repeat burning affects the soil, because recent research by Dr. Uberg at the Arizona Geological Survey and Luke McGuire at U of A shows that repeat burning does have an effect on the soil and may increase risk for post-fire flooding and debris flows. And this study is going to provide more data on that, as well as assisting with Emily's vegetation surveys.
We know you're just getting going. How long do you anticipate the study to last, start to finish?
For this season? Interesting question. So for our soils project, we're expected to go 2 more weeks in the field, potentially a little longer, depending on a couple tricky sites that we have.
And then results could be, well, certainly will be months away before you can really get your arms around the findings and significant.
Right. Correct. Yeah. There's lots of data to process.
Yeah, right. Well, we wish you both the best with it, and we'll have you stand by, because now we're going to bring on Dr. Don Falk, who's going to talk about the tree ring portion of the study. And Doctor, thank you for joining us tonight.
Thanks, Tom. It's great to be here. Because the university is so legendary for tree ring research, we've added a tree ring component to this study. And it's really been enjoyable to add this as a component to this great work. Tree rings make the invisible world of tree growth visible to us. And the way we do this is to take cores from a tree, as you can see being done here. And in case you're wondering, because the question always comes up, no, it doesn't hurt the tree. For the full-grown tree, that core is about the size of a hypodermic needle. So it's just like about the size of getting a COVID shot in your leg. So it's a very small wound that the tree can heal very easily. And the core intersects the growth layers of the tree, which is why we see them as rings. It's a bit like cutting through a layer cake, but we're looking back in time. And this single core that we extracted here from an Arizona pine probably has at least 150 years of annual growth. From those rings, we can learn what trees respond to, what makes them live and grow and die. And of course, we've learned a tremendous amount about Earth's climate using the record of tree rings that go back collectively thousands of years. But in this case, we're asking a more specific question. We're asking, how are trees affected by being exposed to wildfire? How is their growth affected? Surprisingly, this is something that we really don't know that much about, because individual trees are so different in how well they can resist or tolerate fire exposure. You would assume that fire would always hurt tree growth because it scorches foliage and reduces the capacity for photosynthesis. But in fact, in a lot of cases following a fire, we actually see what's called a growth release, an increase in growth. And we think this is for 2 reasons. One, there's a pulse of nutrients that become available to the surviving trees that are actually mineralized in the soil. And second, fire sometimes clears away all your competitors and leaves you the only one with more resources available to you. So this is just a snapshot of how we're using tree rings to understand the growth response following fire exposure. And in so doing, we can build our understanding of how forests can be resilient to fire.
And we should point out, we had a little chat on Zoom last night, and you were telling us how that core sample we saw in the video was a perfect sample.
I was so
congratulations.
Yes. Anytime you do a live demo with your students around, especially, you're really, really crossing your fingers that it comes out well. And I will say that, you know, it's no coincidence that the tree ring lab founded here in the 1930s was so successful, because the conifer forests of the Southwest have a very clear climate signal. And it was really fortuitously the perfect place to begin the founding of this discipline.
And Don, we'll ask you about a theme that's been resonating tonight, and that is multiple disciplines coming together, collaborating on studies in the aftermath of the Bighorn Fire. Why is that multidisciplinary approach so unusual, yet so important to all of you?
Oh, gosh, because the simple answer is that ecosystems are doing everything all the time. The plants are doing physiology, they're growing, there's soil, there are microbes in the soil, there's wildlife, which we haven't even talked about. There are human interactions, both contemporary and historical human interactions with the ecosystems. So the ecosystem cuts across all these fields. It's only our limited mind and time that we have to study these things that forces us to kind of look at one thing under a magnifying glass, sometimes literally. But in fact, to really understand the ecosystem in full, you've got to mobilize as many different perspectives as possible. And we've really benefited tremendously from working with our colleagues studying soil and water. And there's so many more things that we would love to add on these very complex ecosystems.
What is your timeline, Don? You know, you and Rebecca and Emily are working on this aspect. You know, Ben and Julio, everyone, so many people, Liz, from different aspects of research. What would you consider a fair timeline to really have something to grab onto and begin to move forward with?
Yeah. I think if we can come up and study these plots every year for, say, the next 150 years, we'd be getting a handle on it. And I'm not kidding, because really we have to think in forest time. We are so impatient. We want something to happen next year. I got to get that paper out. I want to, graduate, finish my degree. But the human time scale is just not relevant to how ecosystems develop. I would say that we're in the first year of changes that will manifest and unfold over decades, many decades. Some of these things will reach kind of a plateau fairly quickly. And when I say quickly, I mean 10 years. Other things may play out depending how climate change progresses over the rest of the century, because after all, let's remember that wildfire and climate change are inextricably linked in the recovery of these ecosystems. So we can't be impatient. We've got to let natural processes unfold at their own pace. And that is at least multiple years, if not multiple decades.
Yeah, all those variables.
So I will see you up there on the mountain, Tom, and let's say 2080. We'll make a date to go up there and see how things are going.
It's a deal. And it'll be fascinating to find out, because as you mentioned, all the variables, the climate change, future fires, you take it from the sweet spot to the hot spot and back again. The science is inexact science, I guess, at the end of the day. And until you can really hone in on what you've been looking for.
I'll just add that that time axis works the same going back in time. Until we really developed the science of tree rings, our time view of how ecosystems worked was very limited to the period of observation, And in fact, tree rings now have given us a view back hundreds and thousands of years. So we understand not only climate, but the dynamics of ecosystems. And so looking back and looking forward, I think that we can bracket this ecosystem scale time pretty well. And we'll just all keep our fingers crossed for the recovery and the resilience of our beautiful sky islands.
All right. I will see you on the mountain in 59 years,
Okay,
2080, Don. Thank you.
I'll pack my lunch.
All right. And our thanks as well to Emily and Rebecca. Thank you for your involvement tonight. Joining us now to talk about fire, climate change, and the weather is Dr. Tim Brown, who is research professor at the Desert Research Institute in Reno, Nevada. And Dr. Brown, welcome to you. And talking about your primary interests in academia include the wildland fire, climate, and fire weather connections. Can you start out, please, by explaining the difference between climate and weather?
Well, thank you, Tom, and good evening, everyone. Stephen Colbert once said that climate is made up of 1,000 little weathers. And I think there's certainly truth to that statement. Climate enables fire. Seasonal climate allows for fine fuels such as grasses to grow and also allows for the curing of those fuels. Grass growth, such as we saw in that last slide, results from wet, cool seasons. There's a difference in the fuel availability across those two sides of the fence. And so grass is a significant carrier of fire across the landscape. And in forests, long-term drought will stress trees. Warmer temperatures will result in higher survival and faster development of beetle species. And in that photo, we saw tree mortality from either drought, insects, or both. And in addition to the number of brown trees that we saw, that forest tree density, that could easily carry crown fire. So weather drives fire and fire can drive weather. We saw in that one video during the Carr Fire in Redding, California. That was in July 2018. It was a giant fire whirl or pyro tornado that formed with winds in excess of 140 miles an hour. And in 2020, a few large fires produced notable pyro tornadoes in California and Nevada, including one in Nevada that triggered a tornado warning based on radar detection. So the Bighorn Fire was set up in part by warm and dry atmospheric climate conditions weeks ahead of the event, and then weather took over, starting the fire with a lightning strike, drove the fire with strong winds, and eventually helped with control of the fire by providing some monsoon rain.
Doctor, as we've heard from some of our experts tonight, this Bighorn Fire certainly didn't happen in isolation. Last year, again, fires impacted so many communities in the West, lowland deserts, forested mountains. Looking at this through the lens of climate change, can you help shed light on the growing threat to the wildlands and communities nearby?
Sure. So rising temperatures and extreme dryness exacerbates wildfires. Climate change itself is not starting these fires, but the increasing extent of hot and dry conditions is enabling faster burning large fires and allowing for longer fire seasons. We had a set of maps up earlier that were showing this increasing dryness from 8 different dryness indicators from 2000 to 2015, all across the Western US. All 8 indicators were showing a substantial drying trend, which ultimately leads to increased fuel flammability. But climate change is not a sole factor in these destructive fires. We saw that one sequence of photos taken over roughly a 40-year period from the same location in the Bitterroot National Forest that showed extensive vegetation growth over time, resulting primarily from land management practices of not allowing fire to burn as it would naturally. And then we had up a couple of maps for the Santa Rosa, California region, which was the Tubbs Fire from 2017. And that showed that people moving into a place where fire naturally occurs. And so that's one of the things that we are seeing is a lot of population movement into naturally fire-prone areas. So fire today is the confluence of climate, fuels, and people are responsible for all three.
Another interest of your research is wildland fire management and planning and policy in that realm and the interface between science and decision-making. Can you please talk about user engagement through deliberate co-production of knowledge and how this relates to better fire planning and policy?
Sure. So there are basically 3 different approaches to research, basic, applied, and user-inspired. And all 3 approaches are relevant and have value. For example, it may not be readily obvious, say, how cosmological string theory will affect daily home and work activities, but humans have a thirst for fundamental knowledge to ask questions and seek answers. On the other hand, there are real-world needs to work hand in hand between scientists and practitioners to answer questions and create results that can be put into immediate practice. So it is this user-inspired space where deliberate co-production of knowledge has much influence on planning and policy. This is because the researchers working closely with end users in the research process with set goals of developing and weighing alternatives, formulating decisions, and implementing decisions. Quite frankly, I find that co-production is very fun. It's a very fun area to work in, knowing that your work will have a direct and immediate application to a problem.
Tim, while we have you, can preemptive fire placement help mitigate the devastation of a larger mountain fire?
Potentially so. I think this is one of the areas where I think most land managers would agree that we need to see more controlled fire on landscapes. This reduces hazardous fuels. It can improve the health of ecosystems. Fire, again, is very natural across most of the Western US and many places across the US as a whole. But in the West, yes, this is an area where it would be nice to see increase of this, but there are some challenges because of, well, first of all, fire produces smoke. And so you don't want to smoke out sensitive communities, vulnerable communities to potential health impacts. That's an issue. But also in many of these places, if the forest or the vegetation is an overgrown area, controlling that with fire can be done, but it would come with some challenges.
Yeah, speaking on behalf of all the scientists, I guess, let me ask you, did you ever think that your profession, your career would be this exciting with all the aspects of climate change, the fires we've seen in recent years? Is it at all overwhelming at times to just look at what's going on out there and having to deal with it?
Yes, yes, it is. When I started out in this, it was the mid 1990s. And climate and fire was not particularly popular. Actually, Julio Bettencourt and I did a little work together back in that decade on this idea of climate and fire. And so it has clearly changed over time. Mm-hmm. And, but no, when I started out, I had no idea that this was what it was going to turn out to be. It's a very, very interesting area. And fire, I can't think of another discipline that is as complex as fire because of its, it contains both physical, right, and societal components. So it's a very complex integrated system.
Sure. Yeah, I think all of your fellow scientists and experts would echo your sentiments. Tim, thank you so much. And I'll ask you to stand by as we move to our questions this evening, some good ones rolling in from our participants tonight. And we thank you all for sending questions and being with us this Wednesday evening. I have a question for Ben here from Dominique asking, it's not just buffalo grass, right? What about other invasive species out there, including those in an earlier stage of infestation like stink net? Seems like policies and efforts focused only on controlling one species might miss the mark if they're subsequently replaced by other species. So Ben, what about that?
Great question. And the answer is yes. It's unfortunately a milieu of invasive species, and both annual, like red brome we talked about, and several others, and perennial, living for multiple years, tend to be woodier, such as fountain grass, stinknet, which is in the sunflower family, which is expanding rapidly up in the Phoenix area. Just, I think, hopefully we're ahead of the curve on it here in the Tucson Basin, but it grows rapidly in the spring and dries out. Could go on for a while. So there are multiple species. And I guess it's also when you zoom out at look at the whole Western U.S., it's other species in other communities, from giant reed or rhododendrons and washes, tamarisk in riparian areas, but also cheatgrass or Bromus tectorum. So there really is a whole compendium of species that are driving this fuel load and fire threat. And I think that each one has its own ecological challenges. I think it's also important to keep in mind that in the grassland ecosystem, we also have layman's love grass, which is quite widespread. But that's in the grassland ecosystem that has a fire kind of a ecology or reoccurring fires up there. So each species has its own biology and to address with, but I would say in the desert lowlands, fountain grass and buffalo grass are major challenges. And hopefully it's all about timing. So getting the handle on stink that while its populations are low, cost of control are limited, and we can get ahead of it is critical. So there's a lot of groups focusing on this and staying ahead of the curve, such as the Native Plant Society. We have a cooperative weed management area, and that is cross-jurisdictional, as we've been talking about. So these are multi-agencies working together to address the problem and to deploy, even if they're limited resources, deploy resources to combat it.
All right, Ben, thank you. And we'll move over to Julio Bettencourt now. And Julio, the one participant seems to think that there's some disagreement as to the extent that buffalo grass can be controlled and the Catalinas can be rid of it someday soon. Is it possible to rid the Catalinas of buffalo grass? Totally.
My opinion, and it's fairly well informed, is no. I mean, buffalo grass is pretty much here to stay. And what we can do is actually continue to break up these coalescing patches so that you don't get fires burning into the hundreds and thousands of acres. You could kind of say a similar thing about red brome. Red brome is so prevalent now across the southern part of the Southwest that there's no way that we can eradicate it. Most of these species, once they become naturalized, like red brome and buffalo grass have, you're not going to eradicate them. It's almost impossible. And I'd like to point out that there are very few cases in the United States, in North America, where we've actually eradicated a species. There was a European shrub that was kind of the host species for wheat rust. And because it was an agricultural community across the whole United States with a huge amount of money at stake and lots of stakeholders, they were able to control it, but that was fairly unusual. And so I think we're going to be adapting to this. We're not going to eradicate it, but we're going to do, this is like surgery. There's a cancer there. We can't get rid of it, but we can try all kinds of treatments to slow it down.
All right, Julio, thank you for that. We have a question now aimed at the social sciences perspective of what we're talking about this evening. This is for Liz from Mali. And Molly is asking in the survey, did you ask at all about support for the use of herbicide to control buffalo grass? Liz, was that part of the process?
Yeah, so we did not ask about that in the survey. I can respond, though. I have asked, I've talked to some of the public land managers who are engaged in treating their land for buffalo grass, and I can maybe respond a little bit with what they've told me. Saguaro National Park has done herbicide spraying, and of course, in order to do herbicide spraying, they first had to complete an environmental impact assessment and engage the public and hear about their concerns. And as you can imagine, people in the community sometimes are concerned about the use of herbicide on public lands. But they said that, they invited folks with concerns to come and talk to them about their plans, and those were alleviated and they moved forward. So that's at least the perspective from one public land manager on that issue.
All right, thank you. Thank you, Liz. Question for Emily as you begin your new study, Emily. Is your team looking at the differences between vegetation severity or mortality and soil burn severity in your study?
Yeah, so we're definitely looking at how soil changes after it burns, and then comparing that to what we're seeing in terms of mortality or survivorship in the plants and trees in our sites. And we're not completely sure how those are going to be related, but that's something that we hope to see from our study, is how changes in the soil are reflected in changes in the vegetation, either in survivorship or mortality.
So it's sort of a forensic looking toward the past as well as the future in your study. One sort of leads the other, I imagine.
Yeah. And of course, plants are immensely impacted by soil changes, soils being repellent towards water or nutrient cycling within the soils. And so we're very excited to see how soils changing is affecting what we're seeing in plants.
Great. Okay, and we have a question now for your partner, Rebecca. Rebecca, does neighboring flora affect hydrophobic nature of soils?
Yes, it can to an extent. So something that we've noticed out in the field in the last 2 weeks is that if we were to take an infiltration measurement where there was, say, a log that burned on the soil for a long time, that soil is very likely to be hydrophobic. So yeah, that's something that we've noticed. Areas that tend to be kind of more clear of vegetation, the infiltration rates tend to be a little bit higher, also depending on your burn severity. But yeah, so where there was vegetation that had a long residence time for burning, it seems to negatively affect the soil infiltration.
I have to imagine that the rain we haven't had the last 2 years, but might have this year, the monsoon storms and all, will affect the dynamic you're talking about in a big way.
Right, mm-hmm. Yeah.
Yeah, so that's a variable we can throw in there and then see how that affects what you're looking at in the long term. All right. Stand by, Rebecca. We'll be getting back to all of you. Thank you as the questions roll in. We have one for Don now. Don, how can Pima County master naturalist volunteers, numbering about 50 to 60 people, get involved in field research and public education on this topic?
Yeah, this is a great question. We've thought about it a lot because the number of people who are actually doing formal research, such as Rebecca and Emily have described, is very small compared to the number of people working for the public land managing agencies. And those in turn are very small compared to members of the public. I'll give you just one illustration. One of the tools we use in our work is repeat photography. And we seek out photographs that had a good, what's called a georeference. We can put a pin on it in a map or in Google Earth. And we can go back to that site, stand at the same point, and aim the camera in the same direction. And maybe if there was plot data, we could record some of the plot data, and in so doing, get a picture of how this the forest is evolving over time. So there's a tremendous amount of opportunity for people to be observant. Many cases of that kind of science driven by people just with a passion. The great example for us here in Tucson, of course, is Dave Bertelsen, who's hiked the up into the Catalinas thousands of times, and with keen observation really contributed to our scientific observation. A lot of times people view natural history observation as kind of the poor cousin of, so-called real science. I don't see it that way at all. I think the keen observation of a dedicated amateur, whether it's birds or trees or soil or anything, can definitely be as good as any observation that we might make in a formal sense.
Strength in numbers, yeah, and perspectives, like
right.
You say, yeah.
Absolutely.
All right, thank you. Next question for Don. Can preemptive fire placement help mitigate the devastation of a larger mountain fire?
Yes. It's interesting that to use the phrase preemptive, implying that we somehow need to make it happen. Let's remember that not that long ago, these fires were getting lightning initiated fires very frequently, 2 to 10 years at any given site. And so really what the question is for a mountain range the size of the Catalinas is, are there places where we could allow natural progressions to progress? And in so doing, do some of the work of fuel reduction. Of course, for those of you who have been watching the Catalinas for a while, you may remember the 2015 Finger Rock Fire, which started off looking a lot like the Bighorn Fire, burned up at the Finger Rock Canyon, lightning ignited. But the outcome of that fire was very, very different. It did a lot of good work. It was as close to a historical fire that as we've seen. So the problem with fairly compact landscapes like the Sky Islands, and they're big when you're in the middle of them, but they're compact when you look at them from space, is that you don't have a lot of room to make mistakes. You've got summer haven, you've got telescopes, you've got infrastructure, you have the foothills down below. So there are limited areas where you can get away with this kind of natural fire use. In mountain ranges like the Rincons or in the Gila Wilderness, you have more latitude to do that. In fact, the agencies are doing just that. Because let's remember, when we talk about resilience, that doesn't mean fixing nature and not preventing it from changing. We're not trying to hold it in place and keep it in the same state that it was in 20 years ago or 100 years ago. Resilience in a natural system means adapting to change. And that includes adapting to future climate change. So fire is going to play a role with that by selecting species that will do well under future climates. So there's definitely a role for what the question is asking.
All right, Don, thank you. We had you doing double duty there, a couple of questions. So thanks so much. And please stand by as we move on to Tim. And the question for Tim this evening, how is the science connecting to policy? Tim, you want to tackle that one?
How is science connecting to policy? Well, the land management agencies definitely want to use the best science to guide the establishment of the policies. So in talking about, say, use of prescribed fire, there are a number of studies that have been undertaken that show that prescribed fire can indeed reduce the severity of wildfire. If you have an area on one side of a prescribed burn and that fire moves into that prescribed fire space, there will be less fuels to burn. And so generally speaking then, or typically speaking, that does reduce the fire severity for that. Science also drives analyses. It can drive tool development, the things that can be used for data and information to inform decision making, or both daily tactical operations as well as strategic planning.
All right, thank you. And please stand by. Maybe getting back to you shortly. Next question for Julio. And that is, last summer, there was also a fire in the Rincon Mountains right after the Bighorn Fire. It burned during dry, windy conditions because we never really did get much rain last year, but it never expanded into a massive conflagration that like the Bighorn Fire did. And why is that?
Well, I'm not sure why that fire didn't spread the way it did. The conditions might have been slightly different. The fuels might have been slightly different. It's a lot of times these things are whimsical, and a lot of times it has to do with the wind speed and the wind directions, and just the trajectory of fuels that the fire catches, and where it can get really out of control. But I live in Reston, Virginia. I'm calling from Reston, Virginia now, and so I was not, I'm not aware of what that fire was doing, but maybe Don or others have the answer.
Okay, well, thank you. Yeah, a lot of variables that you being 2,500 miles away, and all fair enough that you might not have quite a handle on that. But maybe I'll ask Ben that question, and also Ben. The hillside where one of our participants lives in Rancho San Vacas, bordering the national forest, is tinder dry. Buffalo grass has taken over the hillside. So any ideas for this year in regard to fire suppression on the mountain, and what are the most effective types of controls that land managers are using against buffalo grass?
Sure. So I'll first kind of address the question that Julio was asked too. So yeah, that fire I saw in the news. It was started kind of in the Mica Mountain area, And I was like, oh my God, here we go again. But it just kind of smoldered and didn't get into a crown fire. And it was actually seemed to be a really healthy fire. And I think, again, this is from what I'm understanding and learning actually from the webinar series of last year. It seems to be it's a history of fire management, where on the Catalina Mountains, it's been all about suppression and this massive buildup of fuels. Whereas on the Rincons, as I understand, it's really been kind of the opposite of letting fires more naturally progress and not tamping them down, letting them burn. There aren't as many economic or real estate concerns, and it's more wilderness. And so I think that my reading of it was that it's really about a history of fire management and fuel suppression leading to a buildup, fire suppression leading to a buildup of fuels on the Catalinas, and a kind of the opposite situation that led to a healthier outcome for the fire on the Catalinas and on the Rincons, excuse me. Regarding the bufflegrass infestation question, one of the things that was really interesting in our reconnaissance work of this study was really walking that line of the fire edge and trying to look at the fuels that carried that fire, and also why the Bighorn Fire died out where it did. And so the fuels was a mix of invasive and native species, patches of bufflegrass, but again, that bufflegrass had it colonized up there. But what was really clear, and this addresses the kind of the mitigation management practices, is an adaptive management, that the fire died out on fire breaks. These were either done by the hotshot crews that went in and dug the lines, and in a couple places were remarkably effective, and in several places we saw them save remarkable groves of saguaros by cutting about a meter or 3 foot wide line. In other places there were game trails, and that fire break was enough to stop the fire from advancing, in this case as it descended down slope. So I think, some adaptive management techniques we may want to look at if we're not able to get out ahead and control vast amounts of bufflegrass in the time frame ahead of fire season. We may want to consider adding fire breaks, and that can help kind of protect assets. I don't think that's an answer alone, but I think it's maybe part of the mix.
All right, Ben, thank you. And I want to thank everyone for fielding the questions so nicely tonight, and we appreciate your thoughts. And before we go this evening, we're going to hear some parting thoughts on this complex subject from Dr. Greg Garfin, who is Director of Science Translation and Outreach for the Arizona Institutes for Resilience. And Doctor, welcome. Thank you for joining us.
Thank you, Tom. This is a fascinating evening with really fabulous questions from folks who've tuned in. As we've learned, in our backyard and throughout Arizona and the southwestern United States, we have challenges with fire on public and also private lands. Fuel accumulation from the suppression of fire, as we've learned, is one challenge. Climate change is an amplifier of fire and forest mortality, combining with fuel accumulation to produce fires of greater severity and larger acreage during a more arid fire season. As we've learned tonight, and from last year's series, and from ongoing research, resilience can mean many things, such as recovery and renewal of pre-existing conditions. It can also mean transformation to a different state, where some post-fire landscapes may see increases in the introduction of opportunistic invasive species, what Julio Bettencourt called grassification of the desert, or increases of other species like shrubs, maybe oaks, and decreases of tall stem trees like ponderosa pine and even saguaros at the lower elevations. And these transformations can amplify the risk of future fire. And I'd like to linger on that word transformation, because inherent in transformation is the shift to something different and profound. Changes to the functions of ecosystems, their ability to support wildlife, to protect us from the spread of fire to residential areas and to protect us from massive debris flow erosion, support recreation, provide beauty, and even in some Arizona communities to provide important products. So what can and what must we do in a future with more likely transformation of ecosystems? Well, some of the things we've heard are conduct research to provide insights on the transformation of our landscapes, and also to learn more about resilience to fire and reburn of the landscape, and also public perception of risk and policy actions, including the costs of inaction, mentioned by the University of Arizona research led by Dr. Liz Baldwin. We can support implementation of science-based adaptation strategies to prepare for and recover from fire, support funding and policies that make it easier to implement these strategies. And this includes efforts to remove or disrupt areas of invasive species like buffalo grass that fuel the spread of fire, which, as Liz Baldwin mentioned, has the support of the public. We can prepare through proactive planning, fuel reduction and the budget to maintain treatments, the reintroduction of low-intensity fire in the landscape using prescribed fire, and public education on the risks of these invasive grasses and the benefits of low-intensity fire in our Sky Island mountain ranges. We also need to use our imaginations, because lack of imagination always downplays risk, and we can't afford to downplay risk in a situation as volatile, uncertain, and complex as we see with fire in our region. Scenario planning, which wasn't mentioned much this evening, but it's a much needed method that's coming into greater use to explore and model contingency and worst case situations, in addition to the typical primary and backup plans that we've used for years. And we also need to prepare emotionally to adjust and adapt to a new reality of uncertainty, disruption, and transformation of the ecosystems in our Sky Island mountain ranges. So I'll quote a little bit from an interview, a recent interview with the philosopher Kathleen Dean Moore. She was asked, what's the most difficult thing to write about? And she mentioned hope. And she quoted several fellow authors on the diversity of definitions of hope. The author Rebecca Solnit mentioned, hope isn't like a lottery ticket that you sit on the couch and clutch feeling lucky. Hope is like one of those red axes that you pull out of its glass case to break down doors in an emergency. The climate adaptation leader Susie Moser mentioned, hope is when you reach deep down inside yourself to find the courage and the strength to keep going in hard times. And the environmental activist and Buddhist scholar Joanna Macy mentioned, active hope, and I'll emphasize active, is a decision to find the strength, or if it is hard to find, to build up the muscles, to be an active participant in the work of creating a just and thriving future. So Dr. Moore concludes her remarks by saying, gradually I came to believe that hope is not an emotion, not exactly an act, but rather a way of life. A hopeful life declares independence from the tyranny of outcomes. A person living a hopeful life does what she believes is right and good, not in expectation of some reward or success, but because it is right and good. So while hope is radically disconnected from the expectation of good results, it is closely connected to courage and moral resolution. And as she mentions, she is convinced, joy. So a motto for the future from Dr. Moore and colleagues is, I resolve to do the work. It's a resolve, it's an active strategy in the face of uncertainty and change, like the uncertainty in the nexus of ecological, climatological, and human behavior factors, including the fickleness of politics and policy related to fires in our part of the world. It's a resolve to do all of the prudent stuff that our speakers have mentioned, the science, the preparedness planning for futures that we don't want to imagine, trying new management strategies and practices on the lands in which we live. So let's resolve to be more active, to dedicate ourselves to doing the work regardless of the outcome. And I'm so impressed with many Tucsonans and the members of the University of Arizona community who already show this resolve. So let's resolve and be well-grounded in our courage and resolution to rise to these challenges. And as Dr. Moore mentions, let's do it with joy. Thanks, Tom.
All right, Greg, thank you for your thoughts and for your nice summary and for your involvement here, as well as your organization's involvement in this critical issue. And we appreciate that very much. Also want to thank Jim Buizer, Ben Wilder, the panelists, the Arizona Institutes for Resilience, and the Desert Laboratory team working behind the scenes. Thank you so much for your time and your expertise to bring us this fascinating program. We want to let everyone know this is being recorded. It'll be posted in about a day. You can access the recording, and you can also view the 3 segments we did last year, that series at environment.arizona.edu/Fire on the Mountain. And you'll see it up there. And on behalf of Arizona Public Media, the Arizona Institutes for Resilience, and the Desert Laboratory on Tumamoc Hill, thank you so much for giving us a large part of your Wednesday evening and for caring enough to be with us tonight. We certainly appreciate it. Have a good night.